This is no ordinary communication device because it can go where our phones can't. There are no phone bills and it's absolutely free. It's immune to network congestion and the software and hardware are open source and not patented. It trades cell towers for peer-to-peer connections and isn't endorsed by big telco companies. Many call this the anti-phone. Simply slide one of these into your pocket and your phone can connect to any other nodes on the Meshtastic network, enabling communication over several miles, even without a carrier signal. This means you stay connected in remote areas where traditional networks can't compete. Okay, so I got this guy perched up here. Pretty good vantage point. Yes, there's glass in the way, but who cares? And I'm gonna go out to, I think potentially out here and see if I can get some messages, and then maybe I'll even go further out to out there and see if I can get some messages. So let's see. All right, so just as a frame of reference, this guy right here is currently receiving messages from a second node, which is all the way up in this building up here. So, you know, we're probably about 1,000 feet, at least 1,000, maybe 2 away, and we are receiving messages right now. Recently, tech-savvy companies like Hunter have taken the lead in implementing LoRa technology in their sprinkler systems to support wireless valves. This first-mover advantage has allowed them to eliminate major costs associated with copper wiring, connection degradation, and lightning damage, positioning them to profit significantly from this innovative approach. And after a month of research and testing dozens of different LoRa devices, I'm going to explain why these tiny, powerful devices might spell the beginning of the end for smartphones. Later in this video, we'll dive into some of the less innocent ways people are exploiting this technology. But first, let's rewind to 2 months ago when I first covered LoRa technology. This is the velocity of viewership for the very first LoRa video I've created. And you can see that it just racked up several million views very rapidly. It turns out I wasn't the only one intrigued by this space. Since then, I've gained even deeper insights into tiny radio technology and received insider information from top engineers in the field like Simon over at MusicWorks. He gave me an exclusive look at the brand new R1 LoRa transceiver, which boasts entirely upgraded hardware, forcing me to conduct several range tests in order to find out how far this mesh device can really go. But first things first, no two ways about it, the R1 is a head turner. With its super clean design, it really showcases the unique 3D printed PLA carbon fiber material, sculpted to disappear in your pocket. And I gotta say, this lavender filament is chef's kiss. The model features 4 different colors: blue, gray, red, and purple, and can be picked up from MusicWorks for $79 USD, ready to plug and play. The new form factor is even thinner than its predecessor, the H1. And I gotta say, it somehow manages to make Apple products look outdated. But the aesthetic is not the only upgrade we get with the R1. When it comes to Meshtastic devices, it's primarily a decision between ESP32 and Nordic Semtech, which produces a suite of RAK products. WisBlock is a ready-to-use modular platform created by RAK, used for creating IoT devices for commercial uses, specializing in efficient power consumption. And this device utilizes the RAK architecture. The reliance on this hardware gives the R1 an upgrade over the Heltec LoRa V3 devices, which I covered in my last video. This device boasts a 5-fold improvement in battery life thanks to the RAK board. With its 1800 mega ampere rechargeable lithium-ion polymer battery, this thing aims for 2 days of battery life, which is perfect for weekend getaways, camping, or music festivals. This device features a WisBlock RAK 4631 mounted on a RAK 19007 baseboard. And this features an onboard solar charge controller. The board also features a button to reset the MCU, as well as a user programming button which performs various functions like powering on the device when it's shut down. It also houses a few LED indicators to denote various states of the device. The red light, for instance, will display when the device is charging. Finally, the device connects to two antennas, one for Bluetooth, and then relies on the 915 megahertz LoRa PCB antenna for communication coverage. This guy is designed for on-the-move scenarios, but if you have a use case where your node could be set in a fixed position, then the RAK WisBoard's modularity can be utilized to swap out the PCB antenna for something better. This device does need a companion device to operate the Meshtastic app and actually connect and communicate with other devices. But the point is that that device can be any type of computer or even an old phone, and it doesn't need to have a SIM or any sort of monthly carrier to do its job here, and that's the beauty.
So the first thing we're going to want to do to set these guys up is download the Meshtastic app to our mobile device. You do not necessarily need the app. The great developers over at Meshtastic have also created a web client that works with any Chromium-based browser, and it works quite well. So you could technically do this through Chrome, but I think the app, at least on iPhone, is a little bit more robust. So I'm gonna go ahead and download that. And now we have this open here. Let's go ahead and give it permissions. We're gonna connect over Bluetooth to our devices, so we wanna give it Bluetooth permissions. And then from there, we just need to connect to our device. So it's going to automatically pick up on any Bluetooth signals that it receives. And we see right here, it picks up on the gray R1 that I have. So what I can do is I can go ahead and select that. Now, if we were using a device that had a screen, it would display a pairing code on the screen and we would enter that in here. But because there's no screen on these devices, there is a fixed code. The code out of the box is 1, 2, 3, 4, 5, 6, and you can modify that code as needed. Obviously, it's not very secure, but the only people who are going to connect with it are people within, Bluetooth range, so it's not that big of a deal. All right, it still says communicating with device. We want to see that message turn green. Let's see here. I'm going to go into settings real quick for Bluetooth. All right, so I'm gonna go into Bluetooth settings real quick. It says we're connected. Let's look at the information here. Okay, so it says we're connected, but it still says communicating with device. So I'm gonna actually kill the mesh app, start it again. Boom, that's what we wanted, subscribe to mesh. So now this device is connected to the gray R1, and when we send messages over in the chat here, it's going to use the LoRa R1 antenna. So you could actually, you could turn off Wi-Fi, you could turn off cellular service. As long as we are paired and connected to our R1, we can send messages to other devices within range on the same channel.
Okay, so I just want to show super quick how these devices actually talk to each other when they're paired and you have the Meshtastic app and you have no other sort of network. So on the left here, I just have an Android phone that is completely unlocked, has no SIM card, and currently the internet is turned off and the only connection it has is Bluetooth, and it's paired with this R1 here. Over here, same deal, no internet, no cellular, and it's paired via Bluetooth with the gray R1 here. And these two are DMing each other over the Meshtastic application. So I can just say, yo, and it comes through almost right away. And I can say, what's up? And you can see the messages come through. There's other things you can do, like sharing your position, GPS, range tests, etc. But these communications are encrypted. They're using the LoRa radio. You're not paying any sort of monthly fee. If the world ends and the grid goes down, these will still work. And then to get a range test going on these, you have to configure both of the devices, and you do it by going to settings. You go to the range test module, and the one that you want to send the messages, you just enable this. I do every 15 seconds as the send interval, and then you go ahead and click save and it'll reboot everything.
And the one that you want to be the receiver, set that send interval to 0, but you need to turn it on both devices. And you can see I have an active range test going right now. Every 15 seconds, it's sending a message. The message is incremented with this sequence. Yeah, so sequence, it'll increment every time it sends one, 1204, 599, and it will say 600 right there. And so it's an easy way to have the devices continue to attempt to connect when you are diverging and moving them away from each other. I should also mention that there is a Linux client if you want to take this to your single board computer or what have you. So it's pretty versatile in that way. So flashing the firmware. This guy's gonna come plug and play, ready to go with the firmware installed. But as upgrades and new releases are pushed out, you may want to upgrade your device. And so the way we do that most easily, I believe, is through flasher.meshtastic.org. The approach is a little bit different based on what hardware you have. So for instance, if we were using the LoRa Heltec V3 and we wanted to flash the firmware over USB, you'd plug in the device, you'd go ahead and select your architecture, you would select your firmware version, and then basically what you can do is you can address your device over USB serial, and then you select update, and it will just automatically update the firmware to your device. Now the equation changes a little bit when you're using the RAK architecture. So RAK is the Nordic Semiconductors, and it's just a little bit different. It's not ESP32 based, but we still plug it in here, and we're gonna go over to the device, drop down here, come over to the Nordic section. This is the RAK 4631. Select the firmware version we want. Alpha is gonna be the most recent. It might be a little dodgy, but that's okay. And then this actually just aired out, so let's go ahead and refresh this. This application is not perfect. But when it comes to microcontrollers, we're in a weird position right now where there's all different approaches as to how to connect to them. There's USB serial, there's CircuitPython, there's this .uf2 approach, and that's what this is going to utilize. Again, we're going to select our device, so RAK 4631. But okay, so the way UF2 works is it gets your computer to recognize the device as a mass storage device. And you'll see that in a second. So it's gonna look like a removable thumb drive, Samsung, external SSD. It's going to look like that. And to get software on it, you drag and drop, I believe it's some sort of zip file, and it just automatically reboots, resets, and loads up that software. That's how CircuitPython works, I believe. I'm not a huge fan of this approach, but yeah, I guess, I don't know, in some cases it's preferred. So let's do download UF2. And you can see here, the RAK 4631, it looks like a removable drive. And so we're gonna select this, and we'll go ahead and click save. Yeah, okay, so it restarts the device, but then it also removes it ejects the device, right? So the device is no longer displayed as a removable device. That's how this UF2 approach works. Okay, so let's go ahead and take this out. And let's see here. So we selected 23.14. And so what I can do is I usually connect this to my phone, but we can actually connect it to the browser real quick just to verify that the new operating system is working. So actually we don't even need to connect over USB serial. So let's just go to client.meshtastic.org, new device, Bluetooth, blue, that's obviously that device. Okay, looks like we're connected. We should be able to find the firmware version somewhere. 231464531FA, 231464531FA. So we did in fact successfully install that alpha firmware version. It's been said to, because right, there's different ways you can connect to the device. It has a Bluetooth connection, has USB serial. It's been said when you're flashing the firmware, don't use Bluetooth, because if it drops a packet mid-update, you can brick yourself. And apparently Bluetooth is more prone to doing that than USB serial. So again, different ways to do it, but you can see it's trivially easy using these applications. So I would suggest going this route. Okay, and I alluded to some of the more gray hat uses of this technology and stumbled upon this really intriguing blog post here, where this user basically was able to send a LoRa message without a LoRa antenna or chip. And they were able to do that by using a microcontroller and modulating a certain radio frequency, which was able to send messages to other devices within the vicinity, which is super interesting because when we think about the term air gap, we think that this provides or connotates some form of security. But she demonstrates here that any semiconductor can actually emit radio frequency and therefore send data to other devices that are listening.
Whether you're sold or not, you've got to admit that there's something rather captivating about this libertarian, dystopic, tiny tech movement that may just have a place in the future of how we connect. To stay ahead of the tech curve, check out this next video. Thanks.